generate the address, that is the actual address or the physical address at which location the process or its data or the instructions that are stored. For that, what you have to do, you have to generate the actual or the physical address. Okay, and therefore address binding is required. Okay, so what is happening here? It associates each data element with memory address, and then it try to bind the location. Means it will bind the logical location or logical address with the actual address or the relocatable address. That is called the relocatable. Means that relocatable means that where the actual process is located in the main memory, that is your relocatable address. Okay, and you have to go to that particular location. So when we go for, just a minute, at a class in chair. So when we go for running a program, what happens? A source program is sent to the compiler or assembler. Okay, at the time taken by the compiler, that is called the compile time, and the compiler will give you a object code or dot class file, you can say, in object oriented programming language, or you can say that in your C program like that. Okay, if you give the source program as input, you will get some compiled version of the program. Okay, and then you have to call the linkage editor, and that linkage editor will link the object modules. Finally you have to call the load module. Okay, finally you have to load module, and using the loader you can go for the in-memory binary images. Okay, so dynamic linking is done at the end, but initially when you have the source program, you don't have about the concept of the object module and the load module, other module, etc. But these are the things that are getting done inside the program running period. Means when you are going for running a program, then these things are happening actually. First of all, compilation, and during the running, during your interpretation, then at the time this loading, linking, these are done. Okay, and programs are run. Now you see that what is compile time, what is load time, and what is execution time, that are written here. Compile time means that if the memory location known a priori. A priori means what? A priori means that previously. Okay, if you know the memory location previously, absolute code can be generated and must recompile code if starting location changes. Okay, that means first of all, one thing is there, that is that you know previously, you know the memory location where your code is actually staying, so you can get the absolute code and you can run that one. Otherwise, you must have to recompile the code if the starting location of the code changes. Okay, that is the base location. Base location changes, at that time you have to recompile the code. Next one is the next one is the load time. So compile time is fine. Next one is the load time. So what is the load time? It must generate the relocatable code if memory location is not known at compile time. Okay, so the relocatable code will be generated if you don't get the memory location during the compilation. Next one is the execution time, that is if the process can be moved during its execution from one memory segment to another, then that is possible by using at the time of execution time. Okay, so we can move we can move a particular process from its one execution memory location to another execution memory location. Okay, that is called from one memory segment to another memory segment. Okay, so this is possible during the execution time. Now, so this thing is already explained to you about the concept of this thing. Now the MMU. This MMU is called the Memory Management Unit. Okay. So this particular hardware device that run to actually convert or map, not to convert, actually map the logical address with the physical address. Means which logical address is mapped to which physical address, this will be done by the memory management unit. So why it is written as the virtual address? Because I told you that logical address is the virtual address. Logical address is the alternative name or the alias of this logical address is called the virtual address. So this memory management unit is responsible for mapping the logical address to the physical address. Okay. So you can see the diagram here where the mapping is done. First of all, CPU will generate which address? Logical address. Suppose the address value is 346. This may be anything. I am just considering this one. Now, in the memory management unit, you have the relocation register. Therefore, I was telling that will be the relocatable code. Okay, relocatable code will be generated. So for that, you need to have the relocation register, and the relocation register will contain some value over there. So the value of the relocation register will be added with the logical address to get the actual or the physical address, and that will be stored in the relocatable register. Okay, so this is the particular physical memory address. So suppose this register is starting from 14,000 and this is the suppose base value here, and it may be going to up to 14,346 or more than that. This value should be present in that particular location. Okay. Now the contiguous location. Contiguous means what? Multiple processes will stay in the memory, but that will be one by one. Okay, the sequence will be there. So from 0, then 2,56,000, then 3,40,000, then 4,20,000, 940. These are the memory address values, and I have given the example of the base and limit. I have explained that one in the first slide that you know. So about the contiguous allocation, if we can explain about that, we can see that the main memory has two partitions. Okay, one is the resident operating system. Okay, that is usually held in low memory location. Okay, so I told you that in the main memory we have first of all the priority for the operating system, because the operating system is the first process that will be loaded in the main memory to start the computer. Okay, and that is kept in the low memory. Low memory means what? Low memory means that low address memory. Means suppose your memory is starting from 0 and it is going up to 10 lakh, then from 0 to some particular address, up to that it will be reserved for the operating system processes. Okay. Now after that location, you are going for the user processes. Okay. User processes then held in the high memory. Generally, this happens. Okay. Each process contains a single contiguous section of memory. That means for the user processes, there will be contiguous section. Contiguous means that there will not be any break. Okay. Whenever a process the size required for the process is completed, then from after that one, the next process will be kept there. Then again the next process will be kept there. In this way, nothing, there will not be any gap in the memory space. Every location will be reserved for a single process. Okay. Multiple partition allocation. So this is a single partition allocation or also multiple partition allocation. This may happens that we can divide memory in several fixed size partition. Okay, that therefore I was telling you about the fragmentation in the last class. Okay, about the fragmentation, that is internal fragmentation and the external fragmentation, that I taught in the class. So they are telling about this thing in this slide. You can see that. So in this multiple partition allocation, you are dividing the memory into multiple fixed size partitions. Okay, suppose you have 10 number of processes and you are going to divide the main memory into 10 number of fragments, or say